Well, welcome. And it's not a great problem, but we would like to have some fun. This is a good problem in this respect. And the problem reads as two balls with equal masses and equal electric charges. I'm going to assume positive, or in a gravitational field on some same vertical line at a distance h from each other. That's right. The lower ball is fixed. This eases the problem, and the upper one begins to fall after being released. At a distance h by 2 from the fixed ball, the velocity of the falling ball becomes 0. It stopped at the middle. Find the initial acceleration immediately after the release and the maximum velocity of the falling ball. The acceleration of free fall is g. Well, there are several things in this problem. We need to find the initial acceleration and we need to find the maximum speed. And we all have basic concepts like maximum speed. That means the speed of the ball reaches its maximum value at the point where the acceleration of the ball becomes 0. That means the repulsive force balances the force of gravity. So, but simultaneously, we need to find out the initial acceleration. And how can we do this? So, I'm going to equate the energies of the balls in the initial position. That means when they are at distance h from each other, and at the moment the top one stops. When the ball is at a distance h by 2. So I'm going to start writing the equations, the energy equations, and I've settled the datum 0 potential energy level here at the bottom ball, fixed ball, and so that I can write the initial energy of the ball that is falling, that will be mgh, the gravitational potential energy with respect to the reference level, plus potential electrostatic potential energy, that is going to be q square 4 pi epsilon naught h. And when it is stopped, at that moment the gravitational potential energy will simply become mgh by 2, and its potential energy will be q square 4 pi epsilon naught h by 2. And after revisiting the equation, we found out that we can write something like mgh by 2 plus q square by 4 pi epsilon naught h equal to q square by 2 pi epsilon naught h. And we got something like after making manipulations, we are going to get q square by 4 pi epsilon naught h will be equal to mgh by 2. That means we finally got something like q square by 4 pi epsilon naught h square, and that is going to be half mg. We will need this relation. And you can see, if you can see, the initial acceleration of the falling ball is equal to g by 2, because at the very initial moment there will be forces like mg and the electrostatic repulsion, that is exactly q square by 4 pi epsilon naught h square. And we can write an equation like mg minus q square by 4 pi epsilon naught h square equal to ma at the initial moment. And we know this whole thing is going to be half mg. half of mg. That means mg minus mg by 2 is we are going to get like mg by 2 equals ma. So initial moment the acceleration is going to be g by 2. It's obvious. So at least we got our first answer, that initial acceleration of the ball is g by 2. And now we need to find the speed of the ball, uh, the maximum speed of the ball, and we know when it is going to happen. When the acceleration becomes zero, that means repulsive forces is balanced by the force of gravity. Suppose the height above the lower ball was h dash at that moment. It happened at a height h dash from the lower ball. So we can write our first equation for Newton's second law of motion, balanced equation of forces, that is q square by 4 pi epsilon naught h dash square, and it's going to be mg. That means if I put q square upon 4 pi epsilon naught equal to half mg h square, this thing is going to be half mg h square, half mg h square divided by h dash square equals mg. And what we got from here, that h square by 2 equals h dash square. That means h dash is simply h upon root 2. And this is one of our observations we will need to find. And then we can write the equation of energy to find out the speed of the ball at the moment when it is maximum. And the energy balance equation we can write here, half mv square is b is the required speed, and plus electrostatic potential energy, that is q square by 4 pi epsilon naught h dash, and plus gravitational potential energy, it is also equal to mg h dash, and that will be equal to the initial energy, that is mgh plus q square by 4 pi epsilon naught h. You can solve it by putting h dash and q square by 4 pi epsilon naught. You can simply write half mgh square, and you are going to solve it all, and you will get the speed eventually comes out under root 3 minus 2 root 2 gh, and that's the answer. And we solved both part of the problem. So thank you very much for watching.